Hello everyone, my name is Brandon Griffin, and today I am going to teach you how to do simple regression and multiple regression in Excel. So to get started in Excel, I need to make sure that I have this data analysis option available in Excel. By default, it is not available, but I need to add this in. So for me, I've already added it in, so it shows up. But if you're doing this for the first time, you need to go File, Options, and you need to go to add-ins, and you need to add in the analysis tool pack. And when you add in the analysis tool pack and hit OK, it should show this data analysis button. You may have to restart Excel, but after you get this data analysis button shown, you can click on it and it'll show a bunch of different data analysis tools. These are statistical tools that you can use to analyze your data in Excel, and they're very powerful. So we are going to be doing regression, and this one button here, regression, applies for both simple and multiple linear regression. So that brings me to my next point. What is regression? Regression is a statistical technique that attempts to explain how an independent variable, or if an independent variable explains or predicts a dependent variable. Another way to say that, it's trying to see if one variable impacts, affects, or predicts an outcome variable. So let me go ahead and give you an example of what we're going to be going through today. So simple regression is one variable predicting one outcome variable, one independent variable or X variable explaining one dependent variable or Y variable. In this example, we have three columns of data. We have the student number, so we have 20 students here. We have the number of hours that the students studied per week, and we also have their final grade. So here, study hours, that is our predictor or our X variable. I'm just going to add X. And grade is our Y or our dependent variable. So in this regression analysis, we want to see if the number of hours that a student studies is going to predict their grade. So already we can kind of see that as, the number of hours that as the number of studying hours increases, so does the grade. But we want to see and just double check if that is actually true. So what we're going to do is we need to go into the data analysis option in Excel. So up here on my top right, I'm on the data tab. I'm going to go to data analysis, and I'm going to select regression. And it opens up this regression menu, and it wants me to input my Y range. So I need to put in all my data for my Y variable, my dependent variable, or the outcome variable. The one that, I have this outcome, and I'm trying to see what variables predict this outcome. So my Y range, that is my grade. So I'm going to select C1 through C21, and it does include labels, so I'm going to select labels. And next, it wants me to input my X range. If I had multiple variables, I would input them here, and they have to be next to each other in a column. But since I just have one X variable here, for X range, I'm going to do B1 through B21. Also, probably don't select the column because sometimes it will give you the error. So just select right where your data is, B1 to B21. And I do have labels, and we could go in here and add different, options such as the constant is 0, different confidence level. But one other thing we're going to change is automatically it wants to output your regression output into a new worksheet. But since I want to have my data here and I want to have everything kind of the same, I'm going to change this output range, and I'm just going to put it, in F1. It really doesn't matter where it's going to be. So here I have my output range F2, and I'm going to hit OK, and it runs this regression analysis. I'm going to go ahead and I'm going to widen these columns up just a little bit so we can see our data. All right, so here we have our regression output. It says summary output, and we have a bunch of different statistical measures here. So multiple R is our correlation. That is essentially all the combined correlations, and since we only have two variables going together, it's our correlation. But let me go ahead and highlight the main things that we're going to be looking at in this analysis. People may have different opinions about what's most important, but for me, this is really what I think is the most important things, in a simple regression analysis, just from a surface level. So our R square value is literally the squared value of our multiple R, or our correlation. And let me go ahead and explain this. R square is essentially the percentage of variance explained in our dependent variable explained by our x variable. To put that in English, essentially it says that study hours account for 27%, 27.7% of the variance in grade. So, for example, the number of hours you study is probably going to have a big impact on grade, but there are other factors as well. Did you eat breakfast? Are you a good test taker? How much sleep did you get the night before? That's for an exam, but maybe throughout the semester, have you taken the exam or have you taken these types of classes before? Maybe you're going through a, difficult time in your life. So R squared is essentially how much of the score of y, or of how much of the y variable is predicted by your x variables. So that's your R squared. So 0.27, it does show that, study hours is a good predictor of y, or it does, show that variance. It's not amazing. 100% means that all the variables predict your dependent variable perfectly. But for now, that's what R squared is. And the next important things that we look at are this p-value and these coefficients. So we have our two variables here. One says intercept and one says study hours. And intercept is your y-intercept. If you go back to your high school math, the equation of a line is y equals mx plus b, right? So you need to decide where your line starts and what's the slope, how steep is it, and does it go up or down? And then your x is the slope. So that is the steepness. So y equals mx plus b is the equation of a line that you probably learned, back in high school, junior high, whatever. So y is your dependent variable. M of x is your slope or steepness, how, steep up or down. And b is your y-intercept. And when people talk about regression formulas, sometimes they may change it up. But in essence, it's essentially y equals mx plus b. Some people will say y equals beta naught or beta 0 as your y-intercept plus beta 1 plus an error term, or y equals a plus bx plus e. But all you need to know is that regression is fitting a line through these points based on, the equation of a line y equals mx plus b. So let's look at our coefficients. So if a student studied 0 hours, their intercept or their grade at 0 study hours would be 75.61%. So if a student, just went to class, but they didn't study outside of class, we would estimate that their grade would be 75.6. Now, our x variable, or our study hours, is our slope. So we say after the 75.6, every additional hour of studying is going to increase your grade by 2.7%. So this is, 75.6. If you studied an additional hour, you would be up to, 78, 79%. So now let's go ahead and look at what is called if these predictors are statistically significant predictors. So in regression, we have these different variables that we're trying to see if they impact the dependent or the y variables. And we may have some variables that, aren't necessarily relevant to our analysis. If we had, the amount of ice cream you ate per day or, per week, that likely, just theoretically, I'm just going to guess that doesn't have a huge influence, on your grade. Or maybe it's if you like drama shows versus, romance shows or something like that. It likely doesn't have an effect on your grade. And there's a statistical test we can do to see if it is statistically significant or relevant to our analysis. And in social science, most statisticians, most people who work statistics, they use a p-value of 0.05. And essentially what a p-value is it assesses if the outcome you're seeing is likely to happen in the population. So we assume that two variables are not related, right? We have to be informed by theory. If study hours is going to be impacted by grade, that's kind of a common sense formula. But if you get into, some more in-depth statistical analysis, it has to be guided by theory. But in general, we assume that two variables are not related to each other. If a p-value, or the likelihood of it occurring in the population, is less than 0.05, it's kind of abnormal, you know? So for two variables to be related to each other, you know, less than 0.05 or less than 5% chance in the population, we're going to assume that, you know, there is a relationship. So if your p-value is less than 0.05, you have what is called a statistically significant predictor. So basically what we're saying here is that, you know, long story short, study hours X is a good predictor of Y because this p-value is less than 0.05. And then this p-value of e to the negative 16, that's overwhelmingly, you know, a significant y-intercept. You know, with this being said, if this were to be some other data, such as, you know, maybe sales data, there's something called extrapolation. So, you know, if we're looking at sales data that's in the millions or hundreds of thousands, you know, our data has to be confined to a specific space. You know, just because we do a regression based on $100,000 worth of sales doesn't mean we can apply the same parameters as something that's like $1 billion in sales. But that's a different lesson for a different day. All we need to know now is that X is a statistically significant predictor of Y. So we can safely assume that, you know, the more you study, the higher your grade is going to be based on this p-value that's less than 0.05. So what regression does is it estimates an equation that we can use to make future predictions. And this is why data analytics and data analysis uses regression. So this is, we can use this for forecasting, we can use this for a lot of different things. But based on this equation that it gave me, I can actually predict a student's grade based on the number of hours that they gave me, or the number of hours that they studied. So what I'm going to do here, I have my intercept of 75.6, I have my study hours of 2.7, and I can actually predict, let's say a student studies, you know, let's say 3.5 hours a week, not 2.5, 3.5 hours a week. I'm going to put the 3.5 over here. I need to build my equation. So y equals mx plus b. What is my b, or what is my y-intercept? That is at 75.6112, you know, all the rest of the decimals. And my slope is my study hours of this 2.7. So if I wanted to, I could build an equation, you know, or some sort of estimator. So here in this yellow shaded square, I'm going to go ahead and build that equation. So equals, so I'm trying to find y, or this estimated for 3.5. I'm going to say if I study, or if a student studies 3.5 hours multiplied by our coefficient of x. So remember, 1 additional hour of studying is going to improve the grade 2.7%. That's what we got from our regression equation. So I can say if you studied 3.5 hours, we do 3.5 times the 2.7. And then we need to add the x-intercept. So we have the slope, and now we need to add the x-intercept. All right, so I'm going to do G21 times G19, or my, you know, estimated amount multiplied by my y-intercept, and that gives me 85.07. So based on my regression equation, I can assume that if a student studies 3.5 hours, they're going to get a score of 85% in this course. And we can illustrate this through a graph. So in Excel, I can do, you know, I can select B1 through C21, and if I hit Insert and go over to Recommended Charts, I can do this graph right here. So on my y-axis here, up and down, I have the percentage. On my x, I have the number of hours that they studied. So I can add some elements. Here, I can add a trend line, so you can see the trend line generally goes up. If I right-click on this trend line here, I can format the trend line, and I can actually have it display the equation here. So this line says that the equation is y equals 2.7039x, that's my x coefficient, plus 75.611, that's my y-intercept. So we can see in general that there is a positive trend, or a positive relationship between these variables. And let's check. So I said if a student studies 3.5 hours per week, they're going to get about an 85 on their GPA, or on their score. So if we go to 3.5 and follow this line up, we can see that it's roughly, you know, 85. Perfect. So simple regression is having one independent variable trying to predict one dependent variable. So study hours predicted grade. If we wanted to use the same example in multiple regression, some other factors that may, relate to this is, maybe, we have study hours, but we could also have how many hours did they spend with a tutor? Did they go to class every day that they had class? And a couple other different factors. Do they exercise every day? Do they have experience in this course? What's their overall GPA? Because I bet, if you have a 4.0 GPA, a perfect GPA, your grade's probably going to be high. So they aren't perfect predictors, but they are going to be better estimators than one variable alone, because there are multiple factors impacting, every decision that we make or every outcome that happens. And this is where we get into multiple regression. So we're going to switch gears a little bit. Simple regression was one independent variable predicting one dependent variable. Multiple regression is multiple X or multiple independent variables predicting one Y or one dependent variable. And this is where we get into our rent example. So when you go to rent an apartment, rent a house, there are multiple factors that, play into the price of the apartment. Some of them, big ones are going to be square footage. How big is the space that you're living in? The number of rooms and the number of bathrooms, and to a certain extent, also the school rating. School rating, that could be, just how well the schools are, but that also may be a proxy for how, affluent the community is. Because I guess, more affluent communities are going to have a higher school rating, which kind of plays into maybe the number of rooms, number of bathrooms, number of square footage. But basically, there are a lot of different variables affecting how this, rent total is going to be calculated. And that is what we're going to be doing today. We're going to be doing multiple regressions. We have multiple variables trying to predict rent. So again, we're going to go to this data tab. We're going to hit data analysis. We're going to go down to regression. And remember, simple regression, multiple regression, they just use this regression button right here. We hit OK. So our Y range, it automatically just pulls the range that I had from the other sheet. I don't want that. My Y, or what I'm trying to, guess what predicts it, my Y value is going to be E1 through E41. And my X range, since I'm selecting more than one variable, I need multiple columns. All your X variables, when you do this, all your X variables need to be next to each other. So you can just do a few over here and then add a few over here. It doesn't necessarily like that very well. So what I'm going to do, each one of these variables is a X variable. So I'm going to select A1, and then I do Control Shift down, Control Shift over. So I go A1 to D41, and I see that my output range wants to put it in F2. I'm going to change it just to G2, just give me another line of space. And when I hit OK, we see our same regression output, but we have a couple additional lines of data. And these are my different variables. So here, let me go ahead and highlight these important concepts again. Again, all of these are important, but these are a little bit more advanced, and for our application today, this is kind of just the bare minimum when you're doing regression. So our R squared, or the percentage of variance explained in the dependent variable by your independent variables, is 0.82. So that means almost all of the variance, or almost all of the change, almost all of the story behind the rent is being predicted by these four variables. 0.82, that's very high. That is very awesome. So that's pretty good. Next, we have our intercept. So that means if square footage was 0, rooms was 0, bathrooms was 0, school rating was 0, you'd still get charged $137.85, $0.86. Square footage means that for every additional square footage of space in the apartment, rent's going to go up by 0.34 cents. That is individual square foot. If we wanted to make it by thousands, we could do that, but I'm going to just leave it at cents. Rooms, for every additional room, in this sample at least, rent's going to go up by $185.33. For every additional bathroom, the price is going to go up $134. And for an increase in school rating, the rent is going to go up by $2. So it doesn't seem to have that big of an effect on, what we're working with here. So let's go ahead and look at this. And then let's look at our p-value. So our intercept, p-value is 0.26. So that means our intercept isn't necessarily perfect in this case, our square footage p-value is less than 0.05. So we can see that square footage is a statistically significant predictor of rent. Rooms is 0.01. So the lower the p-value, the better it is. So 0.05 is not as good as 0.01. So rooms has, 0.01, that is a statistically significant predictor, and bathrooms is 0.056. Now, let me go ahead and say something. The 0.05 cutoff value for p-value, that's just an arbitrary mark that someone threw out there. Just because something's 0.06 p-value like this, or just because of 0.04 p-value, something else, doesn't necessarily mean that this isn't a, relevant predictor. Because there's so many different factors and so many different things going into account in these analyses. If it's close to that 0.05, you can use it. That's a relevant predictor. But when we go down to the school rating, the p-value of 0.87, that means that the change of the rent price based on the school rating is likely just, fluctuation in the market. There's likely no real, change that school rating has, on the charge for rent. So our three statistically significant predictors are the square footage, rooms, and bathrooms. Okay? So we can use these, and actually we can write an equation to predict what the rent would cost if we did a couple different things. So our y-intercept, it's just going to be this 1.37, and then we can predict based on the 4 different x variables what our rent's going to be. So let me come with a hypothetical situation. Square footage, let's say we have an apartment that's 1,200 square feet. We have, how many rooms are we going to have? We're going to have 3 rooms. And how many bathrooms? We're going to have, let's say 1.5 bathrooms. And school rating. Because school rating was not a statistically significant predictor, I probably shouldn't include it in my analysis. But just because, it's in here, I'm going to include it. But in the future, if I wanted to run future analyses, I probably wouldn't include school rating. So actually, I'm just not going to go ahead and include school rating. It wasn't statistically significant. It didn't impact my variables very much, so I'm not going to include it at all. Change my mind. So here I have square footage of 1,200, rooms 3, bathrooms 1.5. So now I need to predict what is my estimated rent. Remember, this is an estimate, estimated rent. So here what I'm going to do, I need to do what is my intercept, 137. Remember the equation of a line. Y equals mx plus b. And that brings up a good point. Let me go ahead and copy this equation of the line. All right, so originally, equation of a line is y equals mx plus b, right? Equation of a line. We have multiple x's, so instead of it being y equals mx plus b, it's going to be y equals mx1, so it's our first variable, plus, mx2 plus mx3 plus our intercept of b. So each one of these m's is actually their own, what's called beta coefficient, this coefficient here. So we have each one of these different variables has their own slope, so it ties in. So the equation of a line goes from this y equals mx plus b, and we expand it a little bit. So we say y m1 x1 plus m2 x2 plus m3 x3 plus your beta coefficient equals your y. So this m1 is equal to the square footage. M2 is equal to this room. Let me go ahead, M2. And then M3. So that's the slope, because you have 3 different slopes coming together trying to estimate this y value or your rent. So this is going to be x1, this is going to be x2, this is going to be x3, and this is going to be our y value. So our estimated rent, let's go ahead and put this together. So I'm doing this based on this formula that I wrote right here. All right, and our intercept would be this b value. So estimated rent, that is going to be, we need to do m1 times x1. So I'm going to do open parentheses, I'm going to do m1, so 0.34 times 1,200. So remember, 1 square foot increase is going to raise the price by 34 cents. Then I need to add m2 times x2, so I'm going to do m2, $185, times 3, plus, open parentheses, I need to do m3, which is bathrooms, 134.67, times 1.5. So I have my 3 variables and their predicted values, and I need to add in the y-intercept or our b value. So when I hit enter, I predict, based on this equation, I predict that a apartment that has 1,200 square feet, that has 3 rooms, and that has 1.5 bathrooms is going to cost $1,307.29. So using multiple regression, this is the value that comes out from all of this work that we're doing right here. So in the future, you could apply this and, maybe predict your rent. You could add more variables, but this is a pretty good list of variables. It's obviously going to change by location. Downtown New York City is going to be a lot more expensive than, somewhere in the Midwest. So, this is highly specific to, maybe this is a certain city or a certain neighborhood somewhere, but this would be relevant in that specific city or the specific area. So why do people use this in business? Why do people use this in data analysis? This can be used to forecast. It can be used for a lot of different reasons, but essentially you can use any number or any independent variable to predict a dependent variable, and you can estimate in the future what that is going to be. So for example, maybe you have 1 million people, visit your website, and you have 20,000 people, return visit to your website. Maybe you can predict, how many purchases you're going to have, or maybe based on your marketing spend and based on a couple different factors, you can assess what your sales are going to be. So there are a bunch of different applications and techniques that you can do in regression to get some meaningful data from your data. So some meaningful interpretations from your data. That's what I'm trying to say. So this is how to do simple regression. This is how to do multiple regression in Excel. This is a very basic example of simple and multiple linear regression. There are other examples, such as curvilinear regression, where it tries to fit a curvilinear relationship between your variables. But this is a very basic example of how to do simple and multiple regression in Excel. And I will say one thing: a lot of people, when they do statistical analysis, they will do it in more advanced software. They may use R, they may use SPSS, they may use Python, SAS. But Excel gives you the exact same answers pretty much. So unless you're doing some really intense, in-depth statistical analysis, you can do regression in Excel. So simple regression is one X variable predicting one Y variable. Multiple regression is multiple X variables predicting one Y variable. Good luck with everything. Again, my name is Brandon Griffin, and go ahead and go to brandonphd.com if you have any other questions. But if not, have a great day and happy learning.